Today I will be discussing about sequences and series. When you say sequence, it is a function whose domain consists of some or all natural numbers. Since it is a function, we can denote it using the functional notation, which is f of 1, f of 2, up until f of 1. But in sequences, we use the terms a sub 1, a sub 2, and a sub n. One term is equivalent to one a sub n. And series, on the other hand, is a summation of all terms in a sequence. One type of sequence is what we call the arithmetic sequence. An arithmetic sequence is a sequence obtained by adding a fixed number to a preceding term. Now, this fixed number is what we call as the common difference. Suppose you're trying to get the common difference in a sequence, and we have a sequence 0, 6, 12, 18, 24. We can find the common difference by first assigning the variables for each term and so on. Now, the basic way of getting the common difference is by subtracting the greater term common difference. And in this case, we can use a sub 1 and a sub 2. We can use a sub 2 minus a sub 1 plus 2b, which in this case becomes 6 minus 0 equals b. Now, another method of solving such way is by using the slope. Now, the slope formula is defined as the change in y all over the change in x. But in this case, we can later on expand it as the first for n minus r. And assume that a sub n and a sub r is equal to 12, and this one is equal to 0. So we can define n that is equal to 3 and r which is equal to 1. Now, substituting, you can get 12 minus 0 all over 3 minus 1 equal to 12 over 2, which is equal to 6. So this is the common difference. Okay? We can have two methods in getting a sub n, where a sub n is any term in a sequence. The two formulas that we are going to use is the recursive formula and the explicit formula. Now, let's try to use the recursive and the explicit formula. First off, let's try recursive. In such case, where this is your sequence, now, in recursive formula, your general form is adding the first quadrant, then n minus 1, plus the common difference. In this case, the common difference is equal to 6. Therefore, you can have the recursive formula as sub n minus 1 plus 6. On the other hand, let's write or the explicit. Now, explicit formula, assume that we have a sub n is equal to a minus b. B is equal to a sub 1 minus the common difference, while a is equal to b common difference. Now, using this example, you can assume that our a sub 1 is equal to 0 and the common difference is equal to 6. Therefore, your a sub n is equal to the first term, common difference times n, then common difference minus the first difference plus 6 minus 0. 6n plus 6. Now we're gonna go for the arithmetic series. When you say series, it's the summation of terms in an arithmetic sequence. Now, we can use the equation used by Carl Gauss in finding the sum of an arithmetic series. Now, by writing this, we can have this one. Suppose that you don't know a sub n. Now we're going to try solving for the series of this arithmetic sequence using both formulas. Now first, let's use this formula by Carl Gauss. S sub n will be equal to n, which is 5, times the first term, plus the last term, or a sub n, which is negative 7, all over 2. Can equate it to negative 6 times 5 all over 2. Cancel both sides. We have 5 times negative 3. So, negative 15. Now, let's write n, which is equal to 5 all over 2. Our first term, which is 1. And then, our n, which is 5 minus 1. And our common difference, which is negative 1 times minus negative 1, which is equal to negative 2, negative 2. Now, solving for this one, we've got negative 8 plus 2, which is equal to negative 6, times 5 all over 2. This is negative 3, and 5 times negative 3 equals negative 15. Of 2n minus 1 from 1 to 100, you can see that this equation is what they call the arithmetic sequence. Now, to get the first term, we're just gonna substitute 1. And then to get the last term, which is equal to a sub 100, a sub 100 is equal to 100 times 2 minus 1, which is 199. Now, substituting in the formula, n times a sub 1 plus a sub n all over 2, we can now have a sub n is equal to n, which is 100, then a sub 1, which is 1, plus a sub n, which is 199 all over 2. Now, you see that is 50 58 times 400, which is equal to 10. Another type of sequence is a geometric sequence. Now, by definition, a geometric sequence is a sequence where each term after the first term is obtained by multiplying the preceding term by a non-zero constant called the common ratio. Now we symbolize the common ratio as r. Now, suppose you have a sub 1 is equal to 32 and our ratio is equal to 1/2. Now, we can get a sub 2 by multiplying the first term, which is the preceding term, times the ratio, which is 1/2. Now, since our a sub 1 is 32, we multiply it by 1/2, we will get 16. Now, a sub 3 is equal to 16 times 1/2, which is equal to 8. And it goes so on until it reaches infinity. Now, we call this kind of series the convergent series. As you can see, we call it convergent because it reaches 0. It is a limit until 0. Now, Convergent series is a type of geometric sequence where R is that is between -1 and 1. So your R can be equal to -1/2, 1/2, 0.5, so on. Another kind of geometric sequence is the divergent. Okay, in a divergent sequence, for example, we have a sub 1 equals 7 and RR is equal to 2. Now, our a sub 2 is equal to 7 times 2, which is 14. And our a sub 3 is equal to 14 times 2, which is equal to 28. You can see that as the n goes larger, the term also goes larger until it reaches the positive infinity. Now, we call this series a divergent sequence, a divergent series in which all terms
as long as it gets bigger, will go to the positive infinity. Unlike the conversion, where CP equals to 0.
In getting a sub n, we have two types of equations to use. Of course, just like the arithmetic sequence, we have the explicit and recursive formula. Now, given this sequence in which there are two missing terms, we're gonna use both equations to find the two terms missing. Now, first up is the explicit formula. Now, this is the general term for the explicit formula. As you can see, our a sub 1 is -2. However, before we can proceed to getting the other terms, we gotta first have to identify what is R. So, for getting R, we're just gonna have to divide the later term to the preceding term. Now, dividing this, we're gonna have 2 as our R. Now, this is the second term, and this is the third term. So, substituting each of it in this equation, we're gonna have a sub 2 is equal to a sub 1, which is -2. Then, R, which is 2, raised to n, 2 minus 1. Okay, so it will equal to -4. So a sub 2 is equal to -4. Now, let's try using a sub 3 let's try getting a sub 3 using the recursive formula. Now, the general term for the recursive formula is this: a sub n minus r times a sub n minus 1. Now, our a sub n is equal to a sub 3. Now, a sub 3 is equal to r, which is 2, times a sub n, which is a sub n minus 1 is a sub 2. Okay, and then since our a sub 2 is -4, just multiply it to 2 and then we have 8 negative 2.
Now, the answer to this problem is 4 and negative 2.
Suppose we have this kind of problem in which we have to insert two geometric means. First off, we can find the common ratio, but simply with these given points, we cannot see what the common ratio is. Now, let's try solving for the common ratio using this as our a sub 4. Now, a sub 4 is equal to a sub 1 times r raised to n minus 1. And our n is 4, so we can replace this by 3. Now, we can solve now for the common ratio since we have a sub 1 and a sub 4. And our a sub 4 is 64. A sub 1 is 4 times r cubed. Now, r cubed now is equal to 64 divided by 4, which is equal to 16. And the cube root of 16 is equal to 2 cube root of 2. Now, this is our common ratio and it is not a rational number. But still, we can use it in this geometric sequence. Now, multiplying this to 4, we have a sub 2 is equal to 8 cube root of 2. And our a sub 3 is equal to 16 cube root of 4. Now, we will start finding the sum of a geometric sequence. Now, we can use this formula in finding the sum of a geometric sequence. It is derived from two kinds of formulas, which are also related to geometric sequence. Now, suppose you have the problem 3, 12, 48 until a sub 7, in which we have to find the sum. We can substitute the following terms in this formula. Now, our a sub 1 is equal to 3 and our common ratio, which is equal to 4. Now, from this equation, we're going to have 3, 1 minus r, which is 4, and our n is equal to 7, all over 1 minus 4, which is equal to negative 3. And then canceling this and this, we can have negative 1 minus 4 raised to 7. Now, simplifying this, you can get sum. Suppose we have this kind of geometric sequence. We can see that it is a convergent sequence. Now, we are going to get for the sum of the following terms. And in doing so, we call this as an infinite geometric sequence, in which it is a convergent sequence. Now, the summation of a convergent sequence is different, and it is derived from the previous equation. And here, where r must not be equal to 1. Okay. Now, as you can see, we can solve this by getting r, which is 1/3, and r e sub 1 is equal to 27. Now, 27 all over 1 minus 1/3, which is 2/3, is equal to 81 all over 2. And this is the sum of the following terms. Well, approximately, this is the sum of the following terms, since it continues until infinity. Suppose we have this kind of problem and we need to find the value of the following geometric sequence. But at first you can see that it is not a geometric sequence. However, we can divide this for 0.45 plus 0.0045 plus 0.12445, so on. Now, as you can see, this is an infinite geometric sequence in which r is equal to 0.01. Now, we need to find the value of this, so we're going to have to find for the sum of these terms, in which we're going to substitute it again into this kind of equation. Now, since our a sub 1 is 0.45 and our r is equal to 0.01, well, we have to minus it 1, which is equal to 0.99. It will equal to 45 all over 99 in fractional notation. And it was equal to 5 all over 11. Now, this is a simplified term of this kind of geometric sequence. Now, if you divide this, you will go back here. Another type of sequence is what we call a harmonic sequence. And by definition, a harmonic sequence is a sequence whose each term is a reciprocal of an arithmetic sequence. The key terms here is reciprocal and arithmetic sequence. Okay? Given that we have a harmonic sequence 1/3, 1/5, and 1/7, and we need to find a sub 24. First thing that we're gonna do is to transform this into an arithmetic sequence. Okay, so it will be equal to 3, 5, and 7 up until 1 all over a sub 24. Now, we're gonna compute for the 24th term of the following sequence and then get its reciprocal to transform it here. Okay. Now, our common difference is equal to 2, and then our a sub 24 can be equal to 3 plus n minus 1 is equal to d. As you can remember, it is equal to the formula for getting a sub n of an arithmetic series. Now, substituting 3 plus our n is 24 minus 1, which is equal to 23. And our common difference, which is equal to 2, you can get 49. So, 49. Now, we're going to get its reciprocal to be able to substitute it to its harmonic sequence equivalent. So, our answer for the harmonic sequence equivalent is 1 all over. To summarize everything, we're gonna have this last challenge in which you need to find the next term of this sequence. If it is arithmetic and it's a geometric and harmonic. First, if it is arithmetic, we're gonna have our common difference is equal to -8. And our next term, which is a sub 3, our a sub 3 will be, using the recursive formula, we have a sub 2 plus the common difference, a minus 8, which is equal to 0. And then next, what if it's a geometric sequence? Now, dividing the second term by the first term, we're going to have the common ratio is equal to 1/2. And multiplying the common ratio to the preceding term, you're going to have 1 in 4. The next term. And then for the harmonic sequence, we're going to have 1 over 16 minus 1 over 8. And then until we reach our r is equal to 1 over 16. Now getting the next term, we're just going to add this. So our 1 over 8 is going to be converted to 2 over 16 plus 1 all over 16, which is equal to 3 all over 16. This is what we call the next term of this harmonic sequence. 4 is for geometric sequence and 0 if it is arithmetic sequence.